Hello everyone who is interested in machinery and engineering and the machine production of parts. Today I dug up mud. It's going to simulate raw material when you buy it, and this could be an example of hot rolled steel, which is not that square when you buy it. That's why we need sometimes to machine it unless the customer is fine enough with rough tolerances on it and surfaces. But we're going to cut this up, and we're going to talk about how you put tolerances and how you make a machine part drawing from raw material to finished. So when you give it to the machinist in the production, he's 100% sure what to do, and it's also possible to make easy without making extra cost in the production. And here we have the hot rolled steel, and imagine the engineer wants a hole in the middle. Let's say it's just a distance up for a bigger project or whatever, from the fundament, from the ground, just to make a slight higher adjustment. And he wants it right in the middle. But this, if we want to find the middle of this, we are not sure whether we should go from the middle of this, the symmetry from each side to the hole, or it should be down here or in the middle, because this one is not parallel at all. So imagine if, I'm going to exaggerate a lot, dimension right here is of course smaller than this one. So the one way to do it parallel, let's say that you put the tolerance, there has to be symmetry of the hole from this to this side. Then we need to machine each side if you want that. Or you could choose to buy cold steel rolled and with higher quality production, and you would actually have somewhat a plus minus 1/10 of a millimeter. So that's another option. But let's say we have hot rolled steel and this shit is not straight. Well, then the machinist has to clamp it down, and he has to machine all the way around. He could also just do the sides and then bong in the middle. But if you are to that point, you would normally just go all the way around, and then you would turn around and you would clamp it with about 2 millimeters at the bottom. So you turn it around and then remove a little bit of thickness. So you should actually order this one in bigger sizes. Let's say this one is 100, and then it's 30 thick, 30 millimeter, we're talking millimeters always. Then you would order it bigger, let's say 120 or 140, whatever is on the possible from the production when you buy it. And then you would have to mill all of it down, and of course you will have bigger or better surfaces unless you adjust your machine so it's rough as crazy. But if you want symmetry between, you could say, why not use CAM Pro. So here is what we're going to do. I'm going to try to make it square as possible to visualize once it's milled, and then I'm going to make some different kind of placements and cuts in it, depth cuts, and then I'm going to draw it in Inventor, and we're going to talk about where should we start with the 0 point or the dimensions where they should be placed, so it's easiest for the machinist to put them up and measure it and put out 0 coordinate for his coordinate system in the machine and mill it. Okay, so I'll cut it. So here's what I somewhat came up with an idea what could be a part that should be on the project. You have the hole in the middle, it's talking about the symmetry on all sides, the hole placement. And then there's a small pocket or an open pocket with a chamfer, quite big chamfer, and then I just made a big 45-degree chamfer here too. And then it has to be square, of course. And I'm gonna draw this, and then we're gonna talk about where it could be a possibility to put out the coordinate system and where should you put the tolerances. Let's get to computer. And here I try to draw example of the dirt mud here. It could be a foot, adjustable foot. And if we go to the top view here, which is left, I draw it in wrong axis. The faces are completely flush, also flush with the chamfer. And you could say that if this hole was moved on the flat bar steel, which we were talking about, the parallelity on each side and also the symmetry to the hole, well, then this one will not be flushed at all and it will stick out. So if we go into the drawing, there's different ways to measure this up. I just made a simple one, and what I'm doing here is, of course, all the other things like thickness you have to put, chamfer, the hole size of 30 millimeter counter bore, 10 millimeter deep, and then you have a diameter of 12.5 hole through all, and then the other one you have a 20 millimeter open pocket and it's 10 deep, and you need a 4 times 45 degree chamber on the edge here. And this is the symbol of centerline bisector. It means that when I use this one and take this side and this side, it finds the exact middle of that. And this is good enough to showcase that the hole has to be placed in the exact of 50 and 50 from doesn't matter which side I take, it has to be right in the middle. And when you make tolerances, there are standards for these, and I could put in, for example, let's say we're just gonna write DIN 27626A, which is a very common, and then it has some more blah blah blah. It's very common standard from German institute they use here in Europe. And this one, if you go look at the website or your book, if you had that, you could see that if you have a distance of 100, which is around here, and we put in M, let's go back to this one, we put in M, it means medium, it has to be in small m, of course. There we go. If you put medium, we look at the medium tolerances, and we go from 30 to 100, and it says 0.3 plus minus millimeter. So that means now the hole is allowed in production to move from the center line 0.3 millimeter to right, left, up, and down on this top view. And this way we can make sure that when we go to the assembly, that the part does not exceed a high limit or a bad tolerance where this surface and this does not flush at all. Let's say this one was moved from top view, these two surfaces from the flat bar and let's call it a feed, would be moved 1 millimeter or more, 5 millimeters. And this way we have now correctly talked about how it should be placed, the tolerances, and also what's important in this part to show the machinist what we want to be made. So to finish off with the center, we could put it here, for example. My computer is slow. And put it here, 50, and then of course you have the 100. I could even remove this one over here. Would definitely be better. I say create. I can alternate set again from this side, and I can say okay, continue, 0 point, I say 50, and at the other side, and I'm done. And of course remove the decimals, we don't want those, we want 0, 50 and 100. And now we have given the machinist a specific place to put out his center of his coordinate system, and he has the possibility of plus minus 0.3 millimeters to move with the hole from our center.